chicka, bow,
Alright, in this video we're going to take a look at solving an exponential functions question. We're going to focus on increasing this time. There will be another video focusing on decreasing. But first let's take a look at the steps. Alright, our first step is we need to identify it as an exponential function. That makes sense. After that we'll identify our variables, create our equation, or also called a rule, determine the desired value of x from the situation, calculate y for the desired value of x using the rule from step 3, and then lastly going back and making sure that we're answering the specific question we were asked. So let's take a look at this process using an example. You pay for a new iPhone with your credit card. The phone costs $400. Unfortunately, you cannot pay for the phone until your birthday, which is in 8 months. Now, if your credit card company charges a monthly interest rate of 2.58%, how much will you be paying for the phone in 8 months' time? So let's take a look at our steps. So first thing we need to do is identify it as an exponential function. A few ways we can do that. One, you may notice that it goes up by a certain factor. That means we're multiplying by a certain amount every time. Good indication of that is you may see words like doubles or triples. It doesn't seem to jump out at us in this case. Next thing we'll notice is that in order for it to be an exponential function, you have to have an initial value or a starting value. We've got that up here. We're told that the phone costs $400, and that's when we purchase it, and then at a later time when we're trying to figure it out, it's actually going to be worth a little bit more. If we don't have an initial value, it can't be an exponential function, because if we take 0 and we multiply it by any number, it still stays 0, so we would never go up or down. Other words you might see are something like appreciating or depreciating. And that just means that it's going up in value or going down in value. And usually that's usually by a certain percent. Well, even though this doesn't say it's appreciating or depreciating, we can tell by the way it's written that it is in fact going up in value. In other words, we pay $400 for the phone initially, but since the credit card company charges us interest, in 8 months' time we'll have to pay more than the $400 that the phone costs. And we can see here that in this case it's going up by 2.58%. So we'll highlight that as well. In other cases you may be shown a graph, or you may see the rule or the equation. That doesn't apply in this case. So let's look at our next step. Next thing we need to do is identify our variables. Now most of you probably use x and y for your variables, so we'll do that. And x in the case of exponential is almost always time. I don't think I've ever seen a situation with an exponential where our independent variable is not time. But I want to be more specific than that. We're going to say, well, what unit of time? In this case, it's months. And it's important to do that because sometimes you may have a question where one part might be in months and another part might be in years. It's quite common to have an annual interest rate and then you have to calculate after a certain number of months. So you may have to do a little conversion there, and it's important that you write it down to keep you on track. For exponential function, y is often value. In this case, we're talking about the cost of our phone or how much we owe the credit card company. So I'm going to be specific here. Rather than just write down value, I'm going to write down the amount owing. And again, the idea there is if I'm specific in identifying my variables, it can help keep me on track. All right, our next step, we have to create our equation or a rule. Now, most equations, you'd read with y equals, so we'll start with that. And then we're going to start with the initial value, which up here we can see is $400, the original purchase price of the phone. After that, we have to calculate our base. Now, the base is the amount that we're multiplying by every time, and that's probably the trickiest part in an exponential function question. So how do we figure out our base? Well, if we owed $400 in 8 months, we could say that we would owe 100%. In other words, we'd owe the whole amount, no more, no less. However, that's not the case. Every month here we have to pay an extra 2.5%. So the amount that we owe is actually going up by 2.5%. So we're going to add that on. And what that basically represents is that after 1 month, we won't owe 100%, but we'll owe 102.58%. 100% for the original purchase price plus the 2.5% interest. And when we're trying to calculate a base, rather than do it as a percentage, in the end we're going to convert to a decimal, 1.0258 in this case. Remember, when it's a percent, to convert from a percent to a decimal, you just move your decimal spot 2 points to the left. So instead of being 1.258, it becomes 1.0258. I also want to mention it's really important that you don't round this number. I know it looks a little bit awkward. We have a lot of decimals, but I don't want you to round it, because if you do, your final answer could be off by quite a bit. So our base is going to go right here next to our initial value, 1.0258. And then lastly, when we write it out, we're going to put our exponent, or x, at the top here. And what that means is that we basically start with the $400 of the cost. We're going to multiply by 1.0258, so 100% plus the 2.58% interest. And we're going to do that for every month that we have to wait before we can pay the credit card. So let's look at our next step here. So step 4, we have to determine the desired value of x. Well, x is our number of months, and in this case, we want to know how much we're going to owe in 8 months, or when x equals 8. Pretty easy here. Our step 5, we're going to calculate y for the desired value of x using our rule. So we want to find out how much we will owe when x is 8 months. So to do that, we can go back to our rule, 400 onto 1.0258. But in this case, instead of writing in x, I can write in 8, because I know we're looking at 8 months. And now to calculate that, we'll bring up our calculator, and let's turn it on. All right, so we start with our 400. We multiply that by 1.0258. And then you should have a power of button. Some of them it's x to the y, like this one. Other times you'll see it y to the power of x, or x. Some other times you'll see what's called a hat button, which looks like 2/3 of a triangle. It kind of looks like that. So let's put it in again. So we have 400 times 1.0258, in this case to the power of 8, and it gives us $490.41. We don't really need to go beyond 2 decimals. It's giving us a ton here, but when we're talking about money, it makes sense to go to the nearest penny. So $490.41. So y equals $490.41. And the last thing for us to do is answer the question. So it says, well, how much will you end up paying for the phone in 8 months' time? And you just write, we'll just write out. All right, so you will end up paying $490.41. And there we go. Now that last step may seem simple, but sometimes you'll have to actually do maybe one more quick step after that. So there you go. We'll have another video for looking at depreciating functions. All right, have a great day.